Alright, so I want to show you some examples of these chords and such and how they can help us solve some of these unknowns on circles, and we're also going to be using angles as well. But here we have this first one. So this is a good example of a problem you might find on the test. Now I have this circle drawn out, and it's not perfect here, but keep in mind these marks represent that these two chords are congruent. Okay. So the question on this one might be, and this is from number 1 in your review, the question, this one is, well, what is x equal to? Okay, so the first thing we want to see is what are we given, so that we know these are congruent, right? And then we know that this angle is 93 degrees. So, but we also know if this is congruent, so are these arcs. And they might look a little off here. It's because of how I drew the circle, but they are the same. Okay, so our problem is, well, what is this equal to? Well, all you got to do is think about this angle, right? Don't let this bottom of this triangle fool you, because the angle of this arc is 93 degrees, and if this chord and this chord are congruent, so are the arcs. So if this one is 93, x is 93 as well. Just look for those similarities. It's one example of a problem you might find. Another one you might find, this is number 2. We have this circle here, and we'll call this L, circle L. And it gives us this chord FG, and it's equal to 4. And we have chord HG, it's equal to 4. And it wants to know what x is, and it also gives this 220 degree angle here as well. Well, what we can see is FG and HG are the same length, so we can say that these chords are congruent. What that also means is these arcs are congruent as well. You might say, we still don't know what they are, right? But we do know that these are equal, and that the other arc on here is 220. The total degrees of this circle will be 360, so if we take 360 minus 220, we'll get 140, and we divide that in half because they're both equal to each other, they're the same, and we would get x equals 70. So this would be 70 degrees, this would be 70 degrees, and that would give us 360 degrees around the circle. So it's another example. Here's one with just some algebra in it, and we have this chord here, we have this chord here, and we have these angles, 127 degrees, 127 degrees. So chord AB is equal to 5x, and chord CD is equal to 3x plus 6. What we know, are these chords related to each other? And we might see that they're both equal to 127 degrees. So then we can say their lengths are also equal to each other. So to solve for x, we can just make 5x equals 3x plus 6. We'll minus 3x, that'll give us 2x equals 6. We'll divide by 2, and x is equal to 3 for that one. Okay. And if we look at another one, there's 4. We have this circle, and it looks more like an egg, but sorry about that, but I'll have to maybe get my compass out, start drawing some of these circles. But here we have a bisector, right? We have this diameter here. It tells us the radius is equal to 6. So we know the whole thing should be equal to 12. And we know this is a right angle, okay? And it wants to know some things like what is the measure of arc JL? So this one right here, right? And it also wants to know what PQ is equal to as well. And let me make sure, pause here, make sure I got all these numbers on here. So I was right, I thought I left off some information. So we also have some more that we need, because just the 6 here wouldn't be enough. But we do have JK, so we know that, or I'm sorry, this line right here, that's equal to 10. Okay, and we also know that the measure of angle J, or the measure of arc JLK is 134. So this whole thing is 134. If we want to figure out what JL is, if we know the whole thing is equal to 134, this looks like it's a right angle, looks like it's a bisector, so if this is 134, we would just divide that by 2, and let me get my calculator, I should be able to do that, but I'll just get my calculator, hold on. So yeah, we just plug that in here. We know this whole thing is 134. Just divide that by 2, because that's a bisector. It's going to cut it in 2 equal arcs. So we divide that by 2, we're going to get 67. This one's 67 degrees. And this one's 67 degrees. Okay. So then we also need to figure out what PQ is. Okay. Now we know that this whole length here is 10. But this is a bisector. It's cutting it in half nicely. So then we have a 5 right here, right? And then what we want to figure out is, what is this thing here, right? Okay. So we want to put ourselves a right triangle in here. You might say, well, we don't have this. Let's make this X. We don't have this, and if we put a line in here, right, like this, you might think we don't have that, right? This is just a radius. It's just running from the center of the circle out. So this is the radius. So this is actually, looks like 6 maybe, right there. Okay. So we got a 6, we got a 5, and then we just need to solve for this A, we'll call it. So then we're going to plug in the Pythagorean theorem. We're going to say A squared plus B squared, which is going to be 5 squared, equals 36. So A squared plus 25 equals 36. So it looks like A squared equals 11. Then we do the square root of 11. That's going to give us 3.3. About 3.3. And that's how you do that one. So you just make a triangle. So we've been learning these triangles for a reason, actually. You're starting to see. So we got one more to do here, and then we'll be done. It should give you plenty of ammo to do the homework. So here we have another one. We have another triangle. We have another circle R. And I want you to find TV. So what is this length? And you're like probably thinking, what in the world? I have nothing here, right? So, but you do. You have other possibilities that you have other things that you can figure out because of things that are already on here. Now this bisector here, it might confuse you a little bit and make you think, make it harder to solve. And this is a bisector, so this should be a right angle there. And then, you know, all these aren't really. Okay, so what can we do to this? So you think about it and say, well, we know what the radius is, right? It's 6 plus 5. So we know this over here is 11, right? And all you have to do, we know this is 6 from here, right? Then we draw a line out to here, and you say, well, I don't know what that is, but you do. It's just a radius. So that's 11. Okay, and then we don't know what will make this X, right? And just make a triangle out of it. So again, we're going to use A squared plus B squared equals C squared. So we have C squared, we will make this A squared. 6 squared plus B squared equals 11 squared. And if we just do our math, we know 11 squared, but I don't. I mean 11 times 11. 121 equals B squared, 36 plus B squared. So we just we minus 36 from that. We get 85. B squared equals 85. Take the square root of 85. And the answer will get 9.2. So this is 9.2. And then we also know that this cuts this in half. So if we want to know what the other side is, it's also x2 equals 9.2. Then if we want to know the whole thing, we just add them together. 9.2 plus 9.2, 18.4, and that's the answer right there. So that's a good example of one that maybe you look at and you think you can't do, but you actually can. So add those to your notebook or use them as reference and complete your homework. You're ready.